Alright, so in this section, 1.4, we're going to be talking about how do we collect data. So when we collect data, what we're trying to do is that we're trying to understand something called causality. So, whoops. Alright, so in section 1.4, we're going to be talking about how do we collect data in order to understand causality. So, first off, here's the data cycle, which is that first we ask a question, then we look at the data, okay? We analyze the data, and then we interpret the data. So when we consider the data, what we're doing is that we're considering what exactly are we interested in and what is the best way to collect it. So a couple of methods in which we can collect data are going to be seen down below. So before we get started, the three main ways of collecting data are either going to be through anecdotes, observational studies, or controlled experiments. Another thing is to note that correlation and causation are different. So just because two things are correlated doesn't mean that they're causing each other. So when we're doing this, when we're talking about causality, we're going to be looking at treatment variables and response or outcome variables. So here's an example. A treatment variable and response variable or outcomes could be the following. We are looking at how different medication has a response to pain. Another one could be looking at different wax brands and how they affect the paint on a car. So when we talk about treatment, it doesn't necessarily have to be in the medical field. It could be a lot of different things and how other things respond to them. So first thing we're going to talk about is anecdotes. So an anecdote is a story that somebody tells about their own experience. They don't necessarily have to be false. One of the reasons that we don't put a lot of stock into them, though, is because there's too many variables that we can't control. So an example of this would be somebody telling us that drinking spiced lemonade cures their, let's say it cures their acne. Okay, so in this example, the spiced lemonade would be the treatment, and their acne would be the response. So here's a couple of different reasons why this isn't scientifically sound. So this would be a great thing that would lead us to another kind of study. But let's say that this person had acne because they were intaking too many other sugary beverages. And maybe when they did the spiced lemonade, it was spiced sugar-free lemonade. And maybe it's not actually the spice or the lemon, maybe it's the lack of other things in their diet. So there's not enough control. Also, what if this person just happened to try this treatment while they were changing from one state of their life to another? So let's say that they just started doing this when they were leaving puberty. Maybe their acne would have cleared up anyway. So if we collect a lot of anecdotes, though, what that becomes is it becomes an observational study. So an observational study is usually made up of a treatment and a control group. Okay, so usually but not always. So we can tell a study is observational because we don't dictate groups and we only ask questions. Okay, so an example of an observational study, or a study that only has to be observational and cannot be controlled, would be asking asking pregnant women if they smoked during pregnancy And then the response could be birth weight. So the reason that this would be observational is because we didn't tell people to smoke during pregnancy, but we just asked them, hey, did you smoke during pregnancy? And then what was the birth weight of the child? Now, if we were going to break this up into a treatment and control group, we would have two different groups. We would have a group that smoked and a group that, well, didn't smoke. So we would say didn't smoke. And we would still be talking about the birth weights. So what the control group does is it gives us something to compare this group to. Okay. Now the next experiment is called a controlled. So in a controlled experiment, researchers actually control the assignments of subjects. So they can either do this purposefully or randomly, and they dictate who goes into the control group and who goes into the treatment group. So we still have two groups, control and treatment, like we did in observational. However, the difference is that researchers dictate who goes into what group. Now we try to make these groups as alike as we can in every way, because what that's going to help us to do is it's going to help us to reduce outside variables that could affect our outcomes. So to try to accomplish this, we try to do a large sample. We try to assign them to groups at random. We try to make our study double-blind, and we try to have a placebo if possible. So sometimes all four of these aren't going to be possible, but we try to do them. So here's why these are important. A sample size increases the likelihood of similarities and differences. So we want our groups to be similar. So like if you're thinking of similarities between groups, what would be ideal is if we had a an infinite amount of twins, right? So we could put one twin into our control group, one twin into our treatment group, and see what happened. The reason we want differences is because let's say that we're testing out a medication. A medication isn't going to be very useful to us if it only works for, say, Caucasian females between the age of 18 to 19 who are 5'8", right? You want differences so that you can see that it works for many different types of things. Random assignment helps us to reduce bias. So it's a bias reduction. Okay, so if we didn't do random assignment, this is kind of a extreme case, but what we could see happening is that, let's say that we were trying to see if exercise affected somebody's mood. Okay, so we've heard a lot that if you exercise, it increases your mood because it releases good chemicals in your brain. But what might happen is if we take people who are differently abled or maybe not fans of a certain kind of exercise, let's say that we made everybody do running, for example, and we put all of these people that were differently abled or who didn't exercise into a running group, and then we took all these people who typically run, and it's their favorite thing in the world to do, and we told them don't run. Well, then what we're going to see is we're going to see extreme sadness or disappointment in both groups. Okay, so what we want to do is that we want to reduce bias. So we want to have a good mixture of people in each group. Now what blinding is that it's whether either the researcher or the participant is unaware of the group they belong to. Okay, so in this case, what this means is, for example, let's say that we're testing out a placebo versus an active drug. We would give them to the participant and we wouldn't tell them whether they were receiving one or the other. So we want to make sure that we don't get any like psychosomatic results. Okay, what blinding also does is it also helps us reduce bias. So let's say that we were trying to test out a diet and we wanted to see if there was any weight loss. Okay, if the researcher is aware that one participant is in, let's say, the weight loss diet while another patient's in the control diet, they might be more likely to give positive affirmation to the person in the diet group than they are to the person in the control group, which could skew the results because we, as human beings, like to make each other happy. So, blind is where either the researcher or the participant is unaware. Now, on top of this, we also have something called double blind, which is where neither is aware. So that means the researcher and the participant, neither of them know who's in what group. This is done by usually having a third party participate between the researcher and the participant. So maybe the researcher puts the medication into envelopes labeled 1, 2, 3, 4, etc., and then randomly assigns them to the patient and then gives them to another person to distribute. That way, there's a line between the researcher and the participant, so nobody's aware of who's getting what until the very end of the study. So, let's look at an example and see if we understand what we just learned.